The Fit Fund Solar Corp is pleased to announce the Durham Power Project, located in the municipality of Clarington, town of Bowmanville. The Durham Power Project is scheduled for 200 kilowatts and will be located on a property at the northeast corner of Simpson Avenue and Baseline Road. The Durham Power Project will provide an economic stimulus to the community, both during the construction phase and subsequently as jobs are created to manage the ongoing facility. The Durham Power Project is slated to be located on Lot 10, Concession 1, Bowmanville. The lot is approximately 2.5 acres and borders Soper Creek. Below is the R-plan of the property, completed in January 2011. This R-plan was undertaken to clarify site borders and to determine which parts are required by the municipality of Clarington for sidewalk easements. The owner has generously donated parts 8, 9, 10, and 11 to the municipality. The area slated for development is Part 1 only, Figure 2. At the same time as the R-plan survey was undertaken, we performed a topographical survey to determine elevations. The area slated for use, Part 1, has elevations ranging from 77.43 meters to 80.32 meters, Figure 3. Floodplain elevation for this area is 82.15 meters. Figure 3. Topographical survey. See entire topographical map, page 12. Figure 4. COLCA floodplain map. The Durham Power Project is a 200 kilowatt solar farm consisting of 4 main physical elements. 1. Solar arrays. 40 pole mounted solar arrays of 5 kilowatt each in size. Each array consists of an aluminum and stainless steel frame designed to hold 24 solar panels, mounted on a galvanized steel base consisting of base mount and approximately 8-foot pole. The array rotates about 200 degrees to follow the sun, and has a tilt-adjust feature to optimize solar power for the different seasons. The array will be designed to tilt to 20 degrees from horizontal, so in the event of a flood, the lower edge of the array can be positioned above the high water. See Figure 7. The solar arrays will be positioned on a grid on the property as shown in Figure 8. This layout has been designed to maximize the distance from Soper Creek and allows for keeping most of the trees and bushes on the lot, with virtually no disturbance near the creek. The panel array measures 6,000 millimeters wide by 6,600 high, and the lower edge is positioned approximately 4 feet 8 inches above the ground at 45-degree tilt from horizontal. The 24 solar panels, measuring approximately 1,000 millimeters by 1,650 millimeters, are separated by 6 to 12 millimeters of space, so rainfall will drain between the panels. Figure 10. The pole mount structure is anchored to the ground through the use of helical piles. A helical pile is a shaft about 3 inches in diameter with 3 screw blades that are screwed into the ground with special equipment, and the up-down loads are transferred to the soil via these blades. Figure 11, right. The helical piles create virtually no soil disturbance other than the obvious displacement by their diameter. Each pole mount will have 4 helical piles anchoring them to the ground. 2. Electrical cabling. The 40 solar arrays are connected to the electrical inverters, located in structure, by means of electrical cabling. In order to minimize the soil disturbance, the cabling will be installed with the directional drilling method. A 3-inch diameter pipe is installed to code, linking each pole mount in a row, 6 rows, and then gathered at the west side towards the electrical station. Figures 13 and 14. The electrical conduit has a guaranteed waterproof junction at each array, and the entire electrical grid is 100% waterproof to the electrical room. From the electrical room, the AC electrical connection will be made overhead to the grid. 3. Electrical station. All the electrical cables terminate at the inverters, which will be housed in a 20-foot by 8-foot structure, a shipping container, Figure 15. This structure will be mounted on elevated piers to protect the contents from water flooding. From here, the electrical cable will be run overhead to the grid. 4. Chain link fencing. The entire site will be enclosed with a 6-foot chain link fence to protect the contents and to prevent anyone from going near the solar arrays. Figure 15. The key environmental issues that we have identified and addressed are: A. Topsoil disturbance. In order to minimize topsoil, we have designed an anchoring system that consists of using drilled-in helical piles, Figure 16. The use of these piles eliminates the use of concrete foundations, thus avoiding any site excavation. The installation of these piles has virtually no soil disturbance, Figure 17. B. Vegetation alteration. As the site vegetation is instrumental in absorbing excess moisture, either by rainfall or overflow flooding, we've designed our site installation to maintain virtually all existing vegetation, with exception of one tree, which will be removed. It is located in the center of the property, and its removal will have minimal effect on the site. All vegetation located near the creek banks will remain undisturbed. C. Flooding displacement. As this property is located in a floodplain, our structures have been designed to have virtually no displacement value. The solar arrays are anchored to the ground with about 4-inch diameter rods and mounted on 8-inch diameter pipes. A flood of 1 meter on the property would be in excess of 8,624 cubic meters of water, and the displacement of the solar mounts would be approximately 1.3 cubic meters, or less than 0.015%. D. Drainage. It is our position that the natural drainage of the property be maintained. As the footprints of the solar arrays have minimal impact on the topography, the property will continue to drain in its natural manner. The Durham Power Project is a development fitting with the strong energy roots of the local community, and its mandate to welcome renewable energy in all its development plans. The Fit Fund Solar Corp is very sensitive to the environmental impact of this project and has worked hard to create a solar project that has minimal impact on the property.